Good afternoon, everyone, and welcome to our webinar. I am Íñigo Serrano. I'm Head of Business Development and Marketing at Bequant. And today we're going to introduce our bandwidth management and TCP optimization solution to ISPs in Philippines. The webinar will be presented by our CEO, Jose Lopez, and will last around 30 minutes. At the end of the session, there will be a questions and answers part, and you can leave your inquiries using the question button on your screen on this application. With no more delay, let Jose begin the presentation. Go ahead, Jose.
Thank you, Íñigo, and thank you, everybody, for attending. I hope you are all well in these difficult times. And let us see what our product can do for your networks. When we say we optimize networks, we mean three things. First, we can accelerate, we can increase the speed that your users experience out of your network. We do that with TCP optimization. Then we can also analyze the traffic, the applications, and also the users, how much they are using your network, who is using it most. And we do that with DPI, Deep Packet Inspection technology. And then shaping, we can limit, we are able to limit the speed of certain applications for certain users at certain times, for instance, when their network is entering congestion. We do that with what we call bandwidth management. So let me begin with the first application, with acceleration. What we do is we go against one very common problem, which is that often your networks feel slower than they should. A user may have, for example, at a certain point, a bandwidth of 10 megabits per second, but applications will often use only a fraction of that and will send at 5 megabits per second when actually there are 5 megabits available. So I'm afraid that you have all been in this situation in which the network is faster than what is being used, and you don't know why your network is feeling slower. And what we managed to do is that we managed to get the applications, which in the end are, if the application is using 5 instead of 10, the user believes that it has 5, not 10, whatever you tell them. And so if we in these situations are able to get the applications to use much more of the bandwidth, so that instead of sending at 5, let's say it sends at 8 or 9 or 10 even. So we try to increase this speed that your user experiences, the one that the applications use. And well, of course, the first question is, why do applications send at a speed lower than it is actually available? And the answer is transport protocols, TCP, UDP. These transport protocols are in fact software that is all the time in any connection, besides both on the server and on the client. It does many things. This, for instance, make sure that data arrives in order, that there are no missing packets, but it also decides at what speed on the server side to send at every point. Because if we imagine, for instance, a Netflix application, the video streaming application, in the data center, it could send at 10 gigabits per second, maybe. But then there are many hops, and then from there's a hop maybe at 1 gigabit per second to internet. Then there's all the internet part, and then when it reaches the ISP, maybe at the end there's a limitation of 10 megabits per second, as in our example. So this server has to find out of these many hops it takes to reach the final destination, maybe 20 or so, that it is actually 10 is actually the optimal speed. And it does so by exploring, basically starting from slow speed and then ramping up to the optimal speed. And this TCP, which is a protocol which has been from the beginning of internet, in general works quite well. But in many situations, however, it tends to be too conservative. Basically, to avoid congestion, many times when deciding when going from slow speed to towards the optimal speed, if the network has variability, if the network has packet losses, or if the network is very far away, it will many times TCP and in fact all trust protocols end up sending at a speed lower than it is actually possible. So we can help in this when in the case of TCP, because it's an open protocol, and it is also the protocol that is used by the most applications, but over 80% of the traffic in the internet, for instance. And we can help with our product, which is an appliance that sits in the network. It is an appliance, but really it's software that we have built that runs on a standard off-the-shelf server. So we provide the software. You have to provide the server, and this when you install our software, this appliance, this equipment has to be placed so that all the traffic goes through it. And then the TCP traffic we optimize, the rest we just let go through. And what we do when we optimize is something that's called a transparent TCP proxy. And this is something that we have not invented. This is not magic. This is something that has been done for over 20 years in all satellite networks, and it has been used by many of the largest wireless carriers like AT&T in the US, or Verizon, or Sprint or in Vodafone and Telefonica in Europe, in the large carriers. It is a functionality that has been used to optimize the transport of data in wireless networks for a long time. The problem is that it is an advanced and expensive functionality, and we have, however, made it available so that it can be used by smaller ISPs. And what does this transparent TCP do? Well, let us show you with this animation, and let's see how it is possible to make the transfer of packets faster just by placing one of these appliances on the path. And let's imagine that you have two servers here on the right, and they want to send 7 packets. So 7 packets, this is an example, but TCP would send maybe like 1, 2, 4 different rounds of packets just to probe the capacity of the link. Then the clients, which will sit here on the left, when they get a round of packets right, they send an acknowledgement packet saying, I got that right, you can send next one. And then on the top, there's a direct path, in this case 5 seconds, so that we see the packets go through. And at the bottom, we will put one of our equipments somewhere in between 2 and 3, right? So now we'll start sending these packets and showing you how this works. And so when the first packet from the first round arrives to us, we already send, as if we were the end client, an acknowledgement packet back to the server saying everything was right. And so when the server gets this, it then sends the second round. And this second round of packets we store in a buffer we keep for every TCP connection, so that when the real acknowledgement comes from the customer, the end client, then we are able to already send this second round. And with this, in this case, for instance, we have gained 4 seconds over the path on the top. And the same will happen with the third round. Another 4 seconds, we gain 4 seconds for every round after the first one, in which we don't get anything. So if we have 17 seconds here, it'll be 25 up there. So we have gained these 7 packets have reached the end customer sooner, and significantly sooner. And so this is due to the fact that we are actually building this buffer in our node in the path, so that in fact for the client, after the first round, it is as if the contents were residing here in your network, in the ISP, and by being closer, it is just faster, as anyone with in TCP or in any kind of communication happens. Being closer is being faster, and so this is one of the keys why we when we say we accelerate, because in this way, this path has been able to get to the optimal to get to a larger speed earlier. And so, and this would in fact be even more if you imagine there was any kind of packet losses, which there always are. If you have wireless networks, but also even in fiber networks these days, you may be a fiber ISP, but the end customer will usually have Wi-Fi in their homes or in their work. So in those situations, there is a wireless hop, and wireless will introduce packet losses always. So if you lose packets here, TCP in principle in these acknowledgement packets has no problem. It says which packets are missing, and so you get them from the server. But in this case, you don't need to go. They don't need to go to the server. We already have those in the buffer we keep here, so we can retransmit much earlier. So we reduce on the one side, we reduce the traffic on this side coming from internet, because the servers no longer have to deliver retransmitted packets, but then also we send those retransmissions earlier, and so we are faster. So this is the second reason why we make your network faster. And then there's the third reason, and it is that when we send out packets from this appliance already in your network, we send them out with our TCP, which is basically the same TCP, the standard TCP, but we have changed just the algorithm for calculating the optimal speed at which to send, and so that we don't get confused with packet losses or with high latencies, and we end up sending as fast as it is actually possible, very much closer to the optimal than what standard TCP gets. And we can show you all this to you with measurements. And this, our product is already in more than 100 ISPs worldwide. And so we have collected samples from, in this case, this is 12 of them. Different ones. You can see that they're fiber, there cable, there's wireless ISPs, there's also this MNO 4G, this cellular mobile ISP that serves, it has 2 million users, all the very different networks. And in all of them, what we always keep 1% of the TCP connections without optimization. The rest we optimize, but 1% at random we leave without optimization, and we measure. And we measure the speed so that we can compare against the speed of the connections that we are optimizing all the time. And in this case, we are, so that we have something more comparable, easily comparable, we have just looked at the traffic to Netflix in these 12 networks from Netflix and we have compared the speed with us and without us in for the Netflix and downloads. And for instance, in this fourth ISP, the wireless ISP, we saw that this is traffic for about a week. In each case, the average was 1.04 megabits per second for the downloads without the optimization, and it was 2.5 for the downloads with optimization. So this means that this network was able to have the Netflix downloads at 2.5, but Netflix was sending at 1 megabit per second when it could have been sending at 2.5. So it's the same network, and now with us it feels much faster, because the customers will judge how fast this network is according to the speed they get, for instance, from Netflix. So for them now, this network is faster, and of course the quality of the video streaming will be better, and there will be fewer stalls. But this is not just TCP, sorry, not just Netflix, it's any TCP application. So browsing will be faster, and so downloads will happen sooner, and in general the network, as we say, will feel faster. So this is in what we do regarding optimization. Now we go to the another functionality, which is the analysis, telling you what is going through your network. We have here, for instance, what we can show in a network for 3 days. This is one of our customers. It has this appliance with quite a lot of traffic, in this case up to, for instance, 15 gigabits per second. This is 3 days of traffic, and for instance, we can tell, this is an example, at this day on the 24th of September at 10 p.m. it was carrying 15.203 gigabits per second, and that was 11.6% was YouTube, 8.3% was Netflix, then Facebook, Instagram. So you can tell at each time which different times of the day, which is which are the applications causing the most traffic. And then you can also see that aggregated, not just in an hourly fashion. And we can not only tell you what applications are using the network, also focus on the analysis of which customers are using the network the most. For instance, we can show you the traffic pattern of any of the subscribers. Well, subscribers for us are IP addresses. So for all the IP addresses of your customers, we can tell what they were doing. For instance, this is the 20 subscribers with the most traffic the last 3 days. There, here you can see that maybe this network, for instance, at that time at 11 p.m. that day, on the Christmas day, last Christmas day, 25th, this was the speed at which those subscribers were the hourly mean. And it looks like this was a network where they have some limit around 13 megabits per second or something like that. And we see that some of these subscribers, when they start, they just use all the bandwidth all the time. And so, well, this is information you can use for diagnosing problems. For instance, seeing if some subscribers have problems at certain times of the day, or you can even see if a certain subscriber uses all the bandwidth all the time. Maybe so you can decide you would rather have that subscriber in your competition's network than in your own. I don't know. We just give you the information, you can use it. And last, with the last functionality we provide you is what we call bandwidth management, which means that we can limit the speed of certain applications for certain users at certain time. So how do we do this? For instance, we allow you to have different policies so that you can do this in a different way for different subscribers, or you can do this, you can set different limits for different applications or for different combinations of applications and subscribers. So for each of these policies, you have to decide what applications you want to limit. And for that, we use DPI. So we see the server names that are in those paths, and we can detect that even in encrypted communications. There's always one, well, there's usually almost always one field that tells us which server, which domain they are using. And from that, but you don't have to find out these. For instance, all YouTube downloads have googlevideo.com there as a server name. But we actually have signatures where we provide all these. So you can easily see which are signature. We have signature for video streaming, for typical, for instance, software updates, from Windows and from Apple or Android. We have all those signatures for you. So we have already a way to tell you can decide what applications to choose from the signatures. And once you choose that, you then also have to choose to which subscribers you want to apply this limit, because maybe you have a certain part of your network which is wireless and another one is fiber. So maybe in that case, you need to apply different limitations for one network which is faster compared to the other one that's slower. So if you can do that by IP address, we can apply different limits. And then of course you have to decide which speed limit to set. So for instance, if you have planned around 10 megabits per second, it might be safe to apply a limit around 5 megabits per second for video streaming, for instance. And why video streaming? I'm talking all the time. Well, it is we have found that video streaming is an application which, if you limit during congestion, it reacts in a very good way, because it just reduces the resolution somewhat, but still you can see the video streaming. And so from a customer point of view, when the ideal is to reduce this kind of contents, which are in fact the most the ones that create the most volume in most operators, video streaming. If you reduce somewhat the resolution of all your users, then there's some room for other applications which suffer more if you actually reduce the speed. For instance, email downloads, or maybe if you, which are more like real-time things that people will experience, that if you reduce the speed, they just take longer. However, the video streaming, if you reduce the speed, the resolution goes down, but you can still watch the movie, for instance. So, and all these, so once you have decided which applications you want to reduce, and for which users and at what speed, you then can choose when to do that, because maybe your network, imagine, is a 1 gigabit, and you can get up to 1 gigabit per second up to internet or data from internet. Well, in that case, maybe you can decide to just have this limitation whenever the traffic is above 800 megabits per second. So in this way, you only actually apply this limitation when it is necessary, when you're reaching congestion. Otherwise, you maybe leave the network without any limitation because it is not necessary. So what we are doing is trying to help you cope with congestion and with the higher traffics that are happening now everywhere around the world because of all these confinement measures that we have, for instance, seen. And so we can show you this, for instance, we can show the effects of limiting video streaming with an experiment we did. This is in a wireless ISP. We implemented for 4 days. We set a 4 megabits per second limit per user, per IP address, for video streaming. Okay, so that all the video streaming from each user, maximum 4 megabits per second. And basically, what we did was, it is in this graph here on the left in the bottom, is we even hours we apply the limitations, odd hours we no limitation. And so if we follow the red line, we can see what was the traffic at the time, the hours where there was limitation, and in gray we can see the traffic, the gigabytes that went through that network during when there was no limitation. And you can see how we have reduced, and it was around 15% the peak traffic. And so this is about 15-20% is how much you can reduce. We have seen in our customers that you can reduce the traffic without any complaints, because in this case we must note that there were no complaints. And so of course, yeah, we cannot do magic. We cannot reduce traffic by 50% and have your customers without any complaints. That probably is not possible. But around 15-20%, it is possible. And in fact, the quality in this case, in fact, we saw that it increased by having this limitation, because we also were measuring the RTT the round trip time, the delay, and we saw it went down. And this is because video streaming traffic tends to take all the bandwidth available, and whether it is high or low. And by doing that, it tends to fill up all the buffers in the path, and so that creates latency. So when you limit it, that doesn't happen. So the advantage that we provide, there are other applications that allow you to do this quality of service, let's say, but we do this, for instance, for TCP traffic, we can manage to do this limitation without dropping any packets, at least of the TCP side, because those acknowledgement packets that I was mentioning at the beginning, there, apart from saying that the data is right, you can also tell the server a window how many packets to send to you. So you can actually limit perfectly well the speed at which you get the data. So you are limiting in the source without dropping any packets, which is much better for quality. And we are also doing this integrated at the same time we do acceleration. How can you do that? Well, for instance, imagine with that limit of 4 megabits per second, we would still be optimizing connections that are maybe at 0.5 megabits per second. We are getting them maybe to 1 megabit per second. We are optimizing them a lot. So we're helping those connections that have a poor reception, for instance. But then a connection that has a good connection, good reception, and is at 3.5 megabits per second, then we don't get it to 7. It just stays there because we have a limit of 4. So we are at the same time benefiting. There's benefit for the customer in a big network. There's always some customers that have good connections, others not so good. So we are allowing everybody to have a more equal share at a time when probably there is a limitation. So, and this is the best that you can do in a network. And we also think that it's easy to configure and the pricing is competitive. So this is all about the functionality we do. Now we see about the implementation, how we do this. We, in many countries, for instance, use dedicated servers. We sell this as an appliance, and when we do so, we put the software on Supermicro servers, which are good quality and not so expensive. And for instance, we can get up to 10 gigabits per second from this server, which already has 10 gigabit per second into SFP plus interfaces and also copper interfaces. And this is around $1,500. And we can get up to 50 gigabits per second from other more powerful servers, which cost around $5,000. This is to show you that we can scale well with hardware, but we can work, in fact, with other brands, with many other brands. And for instance, I mean, for us, a server is, we need an Intel server, and it can be Dell, HP, or doesn't need to be from any of these brands. We just need to have a decent server, and we can qualify. If you tell us which server you have, maybe even already, we will tell you if it is valid for which traffic. You have to tell us how many, for instance, if you have up to 1 gigabit per second, basically very, very basic server like an i5, Core i5, or one of the lowest Xeon CPUs, E3 1220, that with 8 gigabytes of RAM and little of this 60 gigabytes will be enough. Okay, and for the you of course need 3 Ethernet minimum, 1 for management, 2 for the data plane, and then if you need more gigabits, we'll tell you what CPUs are valid. If what you have is already an existing server, just ask us, and we will tell you up to how much that is usable, or what you have to add to make it usable. Okay, so regarding the deployment, it is very straightforward. No integration really is required because we work as a bridge. So that basically when you, if you put us in a link, just connect one side towards the subscribers, the other one towards internet, everything that comes in goes out the other way. You don't need to have any IP address on our side. It's just like as I say, as a bridge. You put it like a bump in the wire in the path. Okay, and it can be just for not just for one link. You can put several links through us, like it can be like an aggregate link. We will put those transparently through us. Okay. Then we do need, at least if you have a minimum of one on this side, another one on this side, 2 ports, and then you need a third one minimum for the management. It's a different port we use here, and there we need an IP address. This is just to connect, to configure, and to see the results. And then we usually recommend that you set up a bypass link. For instance, if you have MikroTik routers here, or if they are Cisco routers, you can use LACP or for instance, active backup bonding from MikroTik, so that basically traffic goes through us. But if we go down for maintenance or whatever, then traffic automatically goes through the other link, and this will be, the decision will be made in tenths of seconds in many cases. Okay, and this is the safest for you. So we have over 100 deployments worldwide in many countries. We are very active in Europe and in the Americas, in the US and South Latin America, also in South Africa. And we are now starting in Asia. We have a large customer, Netnam, in Vietnam, and also one customer already in commercial servers for a few months at ComSpec in the Philippines. And we hope that we now start growing more in the Philippines, because we've seen that we can help a lot. And these are some of our references around the world. There are all kinds of from large carriers up to 50 or even 100 gigabits per second. Some of these customers are up down to 500 megabits per second ISPs or less than that. And so what do our customers say? Well, for instance, our first customer, ComSpec in the Philippines, and about the CTO said, after we install the BQN, we have less customer complaints of slow internet. This is what many customers tell us. He also valued the DPI reports that we produce about what traffic is being used. And all these are tools to let you manage congestion. So other customers, like this ISP in Vietnam, they also did a lot of testing of without, because at the beginning many customers are just very skeptical. So we let you try it out and see what happens in your network. So others, customers like this one in the US, get complaints about the Netflix is buffering or video stream is buffering or is slow, and since he put our plans, he stopped having these problems. So all these in the way, we think that we can help you a lot. But this, of course, comes at a price, which is these are our prices, and we sell you have the way we do this in the Philippines is you have to get the server. As we said, it can be a very relatively inexpensive one, and then we provide you software. It's an ISO file that we provide to you. Like it's very similar to installing a Linux distribution. If you have done that in the past, we provide you instructions, we support you, we help you install it. Once you install it in that server, it's that server already. You don't need an operating system or anything. It's just everything is in what we send you. And that server becomes like a router. So you can then put it in the path and it starts working. And the pricing of the license depends on the throughput. So if it is 500 megabits per second, for instance, it'll be 160.67 US$ per month. Or you can have, if you prefer to have a one-off payment, then it's 2,921. This includes the support for the first year. So depending on how many gigabits per second or megabits per second, you decide what license, and the price is a difference between the two. Okay, and so after this, we can. I think I've covered all the parts, and I don't know, Inigo, if we have had any questions.
Yes, Jose, we have a few. Maybe this one just came that I think you answered if they can. Somebody was asking if he could try it in his network, and the answer. I mean, the answer is yes. It's a free trial. I think you mentioned it during your presentation, so that one is covered. There are a couple of questions regarding.
We can tell them that we offer a free 2-week trial. So
right.
we can provide you this license at no risk to you. You're just installing this in one of your servers, try it out, see what numbers you get, and then if they're not enough or good enough for you, then there's no commitment. You can just keep your server and just use it for something else, and you've lost nothing. But we think that we can help you a lot in a significant way, and then hopefully you stay as our customer.
Okay, so there are a couple of questions regarding relation with the cache. I mean, one person was asking if this product is considered a cache engine, and another person was asking what is the difference with a cache.
Okay, no, it is not a cache. It does some things that are similar to a cache. It is not a cache because a cache will store, for instance, if there is a movie that is being downloaded, it will store that movie that someone is downloading, okay, and then it will use that for many customers that download the same movie. And we don't do that because when we store, we're just storing, we have this small buffer for every session. So this is not used for someone else. In fact, we're carrying many times encrypted traffic. We don't know what we are storing. It's just for this session. And we're just a few rounds of packets ahead. We try to be faster on the internet side, which is usually possible because the limitation is usually on the access side, on the subscriber side. So we are there a little early. We have all the packets ahead of time so as to serve them from closer. So it is similar in the sense that now the customer sees data coming from closer. It is different in the sense that we are not reusing that buffer for other connections or other users. And so it's not, for instance, caches have a problem nowadays that they don't work with encrypted traffic, or they only work if it is, for instance, a cache from Google, then works with Google because Google decrypts internally the data for itself. But nowadays, for instance, that cache from Google will not work for Facebook, for instance, because Facebook is encrypted.
Okay, so another question is regarding MikroTik. One person asked, I mean, he uses MikroTik in his network, and he asked if it is compatible and if he has to do any changes in his network to deploy our product.
No. In fact, many of our customers use MikroTik, and no changes are required. We just need packets to come in to one side and leave the other side. For us, it's not important whether it's MikroTik or Juniper or Cisco.
Okay, another question is, I am a routed network and I have several uplinks on different locations. Do I need to put one server for all, or do I need to put one in every location?
I'm afraid you need to put basically one per location where you go up to internet. I mean, the reason is that, you know, we need the traffic to see the traffic that goes down and up. And so basically, if you have a location, for instance, where you have a data center where you connect with to two operators, that we can handle because we can see the traffic of all the traffic going even to different internet providers. But if it is in a different location, it is not possible. We have to be there. If you have another location where you go to internet. So it's dependent on the locations where you go to, you have your internet service provider. You need you would need one of our appliances in each one of those.
Okay, another question is if our product helps FTTH or just radio access?
No, it helps both. In fact, some of the best results we sometimes get are in fiber networks, FTTH, for different reasons. First, because FTTH with GPON is very fast, but it has a significant jitter, variability in delay. The delays are slow, but they are variable because of the way GPON works. And so that confuses TCP a lot. So we can improve that. And also you have to have into account that even if you're a FTTH network, your customers are probably using Wi-Fi. And so Wi-Fi is adding additional variability and packet losses. So then it is out of that we can also support FTTH and benefit. You can benefit from it. But of course, the thing is to try it out and see it for yourselves.
Okay, thanks, Jose. Another question, this one regards virtualization. If somebody asks if we work in virtual environments or just on physical servers.
Right now, we work only on physical servers. We're working to make it available also on virtual appliances. But as of today, we work on physical servers only.
Okay, another one, somebody is asking if our node shows metrics on the acceleration and on the traffic limitation.
Yes, we provide you with metrics about the speed at which traffic is. For instance, we can show you at what speed it is going with us in red and without us in gray. The speeds for different, for medium RTT, things that are very close, small RTT or medium, or maybe from another continent, and for different metrics for large size, downloads, medium size, small size. And we can also show you, what amounts of traffic are being optimized and how many are being shaped, so limited. So yes, we provide, I think, very useful metrics and graphs for you to see your network.
Okay, someone is asking, what will my subscribers feel if I deploy your product in my network?
They will normally they will feel it faster many times, even in some networks where with speed tests they are not reaching the speed that you are promising. Many times we we have made that closer to the actual speed test that you think they should get, and they will get many times Netflix or video streaming with better resolution and with fewer stalling. And when reaching congestion, if you do something so that all the network users are in a better shape, maybe the ones that would go, let's imagine if they may have a very, very good connection, they could go to 4K resolution. Now in those environments, we would not let them go to 4K. Instead, we keep the bandwidth so that all the other users in your network are at a very decent and with a very decent speed. So in general, they will feel a much better quality of experience.
Okay, Jose, there are two questions about where to place the device. Someone has a load balancer with multiple ISPs, so he's asking where should he deploy it, after the load balancer, or
usually easier to deploy it than between the load balancer and the subscribers, because on the other side we could also be there, but then you will need many more ports, 2 ports per each ISP.
Okay, and another one regarding the deployment is someone has a game, an update cache in his networks, and asking where should it position it, before or after the cache.
We think we would put it between the cache and the subscribers, because we can also optimize the traffic coming from the cache, because we have many cases For instance, some of the cases I showed before, there was a Netflix cache in that network because it was a large network. And maybe in those networks we get less, for instance, less acceleration, but we still get a very significant, for instance, in this case, this MNO 4G, they had the Netflix cache. So these are really the downloads that are happening from a cache that's sitting right next to us. And we can optimize it quite a lot. And this is because of our TCP, because they use a standard TCP, we use our TCP, and we think that that will help you.
Okay, just two more questions. One is, does it also optimize encrypted traffic?
Yes. The encryption TLS happens above TCP, so we optimize it. When we store things, we don't know what they are because they are all encrypted. We are not looking inside those packets, so encryption is not a problem.
Okay, and one last question is, how can I buy your product in Philippines?
Well, basically write to us, sales at Bequant, and then if you try it out and you like it, then you can pay to us with, if it is a monthly thing, with a credit card, and then subscription, or the whole thing you can pay to us by bank transfer or credit card. At this moment, we don't have a local distributor in the Philippines. Probably we will soon have one. Then we will work through that.
Okay, and there's one that just arrived. The routers in my network are already using FQ Codel. What effect does this have if I add Bequant?
The FQ Codel, it will basically have an effect when you're reaching saturation, because when you're reaching saturation, it will make decisions to drop packets earlier than other routers would. So without saturation, basically FQ Codel is really doing nothing. So we will be optimizing, improving the speed of your network when it is not in congestion. Now, in congestion, then we will also be trying to improve the speed, and your router will be doing what FQ Codel does, which is it basically finds out where there are delays and reduces them by doing this. So that will also affect us. So in a way, your router will also help us basically deliver this optimized network with a lower RTT, with a lower latency, because it will be doing this early dropping of packets, to which we will react by sending slower. So I think basically you will have, just as you now probably have a better experience out of that, you will also keep getting that. We have our appliance in networks where they do that, and it seems to work together with us quite well.
And just last question, and it came from two people. They're asking if we do something about TCP sync attacks. How do we manage it?
At this point, we don't do much. We just see those. We have enough capacity to absorb any of those denial of service attacks. So that is not a problem for us. But now, what we are going to, it's not right now, but in our next version, we hope to have it. We can detect those and tell you which IP addresses are getting those attacks or which are producing them. So we will be able to provide you with information about who or where they are coming from. But apart from that, we don't do that. We just don't die out of those attacks because of the way we are designed. These initial handshakes, we just let go through us, so they are not a problem to us.
Okay, so that's been all about questions. There might be some additional ones coming. and so we will answer them after this session. So thank you very much, Jose, and all of the attendees. We are available to you at sales@bequant.com, and we're very happy to be working in Philippines, hoping that we will, of course, do trials with you and help you improve the quality of service in your networks. Thank you very much, and stay safe.
Okay, yes, thank you very much, and keep safe.